Joseph, Rector, STEKOM University. And I would like to thank Ms. Novita, MC, STEKOM University, Indonesia. Now I would like to invite our speaker, Professor Shoba, Department of Computer Science and Engineering, Arunai Engineering College, Tiruvannamalai, for the visiting lecture for the students of STEKOM University. Welcome, ma'am. Take over the session.
Thank you, sir. I welcome you all for this session, those who have joined virtually. Today, actually, I'm going to discuss about machine learning. And for that, let me share the PPT first. Is the PPT visible to all now?
Yes.
Okay, ma'am. Thank you. So, to introduce myself, I am Shoba, from Assistant Professor from the Department of Computer Science and Engineering, and I'm going to handle on the topic exploring the landscapes of machine learning techniques. And to start with, I just want to give an overview about artificial intelligence and machine learning. Artificial intelligence, as we all know, that it is a field wherein we we make the computer think and act as human. Okay, so what do you mean by thinking and acting as human? Is making the computer think and act rationally in the sense, like, whatever is the right thing to do at the right time, you will be able to make the system do it that way. Okay, so then what is machine learning? Okay, so machine learning is something which makes the machine learn from whatever it is performing. Okay, so and in that we have several things to discuss here. And before we start discussing about the other things, so let me go by the definition and the history of machine learning first, and then after that we will get into how a learning system performs and how the design of a learning system will be, and the various classifications likewise will be the session now. So as of now, let me repeat. First, we are going to see the overview of what is machine learning, and then how a learning system is designed. Okay, and the pros and cons, and then we'll get into the types and we'll move accordingly. Okay, so now, what is machine learning and how is it related to artificial intelligence? Like, okay, say for example, how does a human learn right from his childhood? See, initially, with very less knowledge about the environment, a human child will not be able to properly perform in the environment. Like, with whatever experience it gains, it will be able to perform properly. Likewise, a machine is also like that. Like, it has to, perform in the environment, and according to what it performs there, it will be able to, improve its performance. Like, this is the formal definition here what I have given you in the slide. Like, it is a branch of artificial intelligence, okay, which focuses on how the data and the algorithms will help you to make the system learn the way how humans do, and to improve the accuracy. Okay, and the same way, like, we don't have to explicitly program on what to do and how to do. It will do on its own. So this is how machine learning works. And to be more precise, like, given a task, okay, let me explain this with an example. Say, for example, if you are driving for the first time, okay, a child is driving a cycle for the first time. So what will be the task environment for the child that you will give is, like a street which is normally, which is used to the child, and the task to be performed by the child will be limited. Like, say, it has to travel in the road till the end and it has to come back. Okay, so this is what will be the task that will be given to the child, and it is more of like a training session. So if the child is able to complete that, okay, so depending upon the performance, okay, you will be able to assess the child's learning capacity, and depending upon which you will try to fine tune the task environment also. Okay, so meanwhile, while it is driving on the way, it may experience something. Okay, based on the experience what it faces on the way, it will be able to fine tune the performance. So this is how it all happens. And here is a small diagram I have actually shared with you, wherein you have some inputs and some weightages given to that. X1, X2, X3, here I have mentioned, are the inputs, and those carry some weightages. For example, some weightages need to be very large. Like, say, for example, if it comes across, a small, like a bird or something, the child need not panic. By the same way, if it comes across a big vehicle or something, accordingly, it has to adjust the direction in which he moves the handlebar or whatever it is, like, depending upon the vehicle he uses. Okay, so all these inputs together we give the child, and without like, the bias is something that which actually tells you how far is your observation, and based upon that, the activation function will work, and accordingly the child would give the output. Okay, so this is clearly what is happening in machine learning also. Like, a task is given, the performance, according to the performance, the output will be, and with the output he gets, or the agent gets the experience, and depending upon which he'll be able to improve on later. Okay, so what is the actual difference between traditional approach, and why do we, move towards machine learning? Okay, let me explain this to you with an diagram here. Like, normally, what do we traditionally do? Initially, when we see the history of computer science, the artificial intelligence date backs to some 1950s, wherein artificial intelligence itself was like, in its preliminary stage. Um, in that stage and all, will not be able to, even think, like, whether can a computer think, or can it even, like, make decisions on its own. It was like that in that period. And later on, in 1959, its author, who actually coined the term machine learning. And at that time, what is the difference that does he make? is right from structural programming to object oriented programming, actually how we evolved from the basic task solving thing to a structured like in object oriented programming. So it is how we have actually evolved from there to here. Like instead of a programmer writing some rules, okay, to solve a problem. So if you could see the screen now, you could be able to relate to it. Like the programmer studies the problem. Say for example, if he has to solve a tic-tac-toe problem, he has to study the problem, and then if he has to win the game, he has to formulate some rules as of what to do, when to do, what not to do, and all those things he has to define clearly. Okay, and then whatever rules he has written, he just have to evaluate. Sometimes some some test tasks may be given, and based upon those, so after the launch, but in case during evaluation, if he meets with any sort of errors, or if there is any any problem, he has to analyze those errors and then study the problem again in the sense from the perspective of the error. Okay, so how can he get over that problem? So again he can fine tune the rules accordingly. So this is what is a traditional approach of how programming works. But now coming to the learning approach. What is a learning approach? Again, let me take a human example. When we were children, our parents used to say what to do, what not to do. These are all the things that you have to do in the environment. This is what you should do. And as far as we hear to whatever they say, all the outcomes will be as expected, and we'll be doing fine. And there will be one fine day when we have to out of whatever experience we had, okay, depending upon the way how we reacted, how we did certain things, and based upon which we will learn something on our own. It is something like this here. Here the problem is given, based upon which we try to train the machine learning algorithms. Okay, there are several algorithms, the types of which and all we are going to discuss in the forthcoming slides. But these ML programs, what they will do, along with the support of the data that it has gained, okay, out of like either it may be fed by the human, or it might have been self-learned, or whatever it is, that depends on the type. Okay, so whatever data that it gets, the ML machine learning algorithm is trained, and based upon which it gives the it evaluates the solution, and then it launches the actual output. So again here, the error solving is as usual in the tradition. Like if that solution it's not fruitful, or if it is not as we expected, we analyze the errors again, and then the those things has to be modified in the problem, and again you train the algorithm, and this goes on. So you may ask, so why do we have to do all this? Is because this can completely be automated. So like for everything and anything, we don't need intervention of a human or any supervisor or something like that, and we can go on like this. And this diagram shows you how it actually happens. So even after the launch, like you train the ML algorithm, you evaluate the solutions, and you launch them. And after when you launch it, if there is any updations, like if there are any new things that has to be changed, because since it is learning, it should be ready to accept change. Okay, so those changes whatever is given, so those updated data will be like updated, and then it again is used to train the ML algorithm. So this is how the whole thing actually works. So this is all about why machine learning, and these are all some points to tell you why machine learning is important and it is great. Like for whatever is the complex problems that you have, which doesn't have good solutions in a traditional approach, for those things we go for machine learning. And something for which we have to write rules for pages and pages, and that will become hectic for a programmer. And those such problems we can actually, suggest for, like we have fluctuating environment, like say you need to update data then and there. So for those fluctuating environments also we can go for machine learnings. And in some complex problems, those persons who have like a knowledge level 1 or 2, they'll not be sometimes able to analyze complex problems. Even such problems, sometimes can we can find a solution with machine learning. So this is why machine learning is great. And coming up to a learning system design. So normally, why do we have to look into a learning system design? Is because, see, normally artificial intelligence, we all know how agents work, how they get the data and all these things. And now when it comes to learning system, the final design actually carries some of the important things that we need to know. So before designing a learning system, or to get a successful learning system, we need several steps to be followed. Like when you actually design a learning system, the training experience that you give to this system. For example, let us take the same driving example. Okay, to whichever environment that you expose the child to. For example, initially you expose it to the limited road, and then you may take him to a more traffic road. And then likewise, the training experience to give to a learning system, and choosing the training environment is also important. And then the target function, like normally where, why are you actually training, and the way which he chooses, that is the representation for that target function is also important. And the algorithm that is used to train, okay, those algorithms is also in choosing those algorithms also we have to be very careful, because depending upon the environment, like those who are familiar with artificial intelligence would have known about the environment. Like there are several sorts of environment. It may be static or a dynamic environment, or it may be like there are several classifications. And moreover, like how you have different environments, so you have to train on all these things. And the final design of a learning system is like this. See, it has, the final design has some 4 modules. Okay, so these are all the 4 modules of a learning system: the performance system, the critic, the generalizer, and the experiment generator. Okay, so the performance system here is the actual system that which performs in the actual environment. As I told you before, the environment for which you are making the system, that you have to be very clear. Like sometimes it may be a game playing environment, like a football or something like that, or sometimes the environment may be continuous, like in a driving environment. Likewise, you have to be very clear. And we have to choose the algorithm accordingly. So only if that algorithm is proper will the performance system work properly. Then comes the critic, because always a critic is the one that which helps to improve the performance. Like if nobody is commenting on what you are doing, you will not be able to learn till your lifetime. Only if there is some criticism for how you perform, okay, so you will not be able to reach the finest performance. So you need a critic on how you should improve the performance. Then comes the generalizer. The generalizer, in the sense, there should be some benchmark performance, which the critique, can refer, and can make improvements to the performance. So that is called as a generalizer. And last comes the experiment generator. Say, for example, the problem generator. Here the experiment generator is, or otherwise sometimes it is also called as the problem generator. So what does it do? It will give you some new problems to face so that your performance can be tested, and again it can be criticized based on the generalizers standards. Okay, so according to the benchmark, if you are able to handle the problem properly and if you are able to perform it properly, then your performance is, up to the mark. Then this is how it will keep on going. And to understand this further better, here is a diagram for you. See, when a new problem is given to you, okay, so the performance system gives the solution, okay, and when the solution is suggested, the critic is there to comment on how you are performing, and these decisions are made using the generalizer, and these generalizers have some hypothesis with them. I hope you all know what a hypothesis is. What we believe is right, and whatever is, believed to be the proper one will be there in the hypothesis. So those things will be taken into account, and then depending upon which the problem generator will again give some new problems to test your performance. So this is a cycle which will be going on, which will help the learning system learn better. And here are the types of machine learning systems. Here comes all the systems. When it is done under human supervision, okay, when it is done under human supervision, it is classified into supervised, unsupervised, semi-supervised, and reinforcement learning. And whether you are able to learn incrementally or not, you have batch learning and online learning. Okay, and there are also other varieties which is called instance based, okay, and model based learning. So let us see one by one in detail. Okay. Okay, what is the supervised learning? Always when you have a supervisor around you, it is the supervised learning. More of a human intervention will be there normally in such supervised learning. Okay, here what happens is, when human intervention is there, what they'll do is to label the data. Whatever is the training data, okay, those datas will be labeled, and the algorithm will be fed with those pairs, okay, and what is the input and what is the labeled output, and all those things will be fed, okay, and depending upon which the predictions or the classifications will be done, and these classifications actually will be given as output. So this is what is the supervised learning. And coming to this, to make you again to understand better, here I have given you a diagram. See, here is a set of data, which is a labeled data, and the labels are, as you can see below, it is given there. See, if it is a cow or an elephant or a camel, they are specifically labeled, okay, and these inputs are given to the algorithm, and this algorithm is having a backup of labels now. Okay, this makes a major difference, and this is done, with the help of the supervisor. He gives the training data sets, and he observes whether it gets the desired output or not, and based upon this processing will he get the output. That is a learning algorithm will be able to perform. And there are some types of supervised learning, and there are like classification and regression. Classification is whatever, according to the labels what you have, you just classify them. Okay, so they are all discrete values, like not continuous. Okay, so that is why those discrete values are categorized, and such models use this classification algorithm. So for example, when we take the spam detection and all, those things will carry the words, some fancy words like this is an offer, or several other words, okay, like those things can follow this classification algorithm. And next comes the regression. This type actually works well on the continuous value. And here, for example, when you are when you're about to say a location, you cannot actually say that we are here or there like that. So you can rough, like, I am close here, I'm close to this place, I'm here, I'm over here, like it is a continuous data. So in those situations you can go for regression. Okay. And these algorithms are evaluated based on these parameters. Okay. So in supervised learning, as I told you, we have two. One is a classification and the other one is a regression. And for classification, these evaluation measures we have. So how accurate is it and how precise they are. Okay. And how many positives you have properly recalled. So that is one of the other evaluation parameter. And this F1 score is a combination of the precision and the recall. Okay. And the other one what we have is that ROC curve and AUC. That is depending upon the false positive and the false negative, the curve, how far, if the curve value, the area under the curve, AUC is area under the curve. If that is nearly some 0.8 or something, then you can say that it is good. Okay. The confusion matrix is wherein when there is a confusion on deciding which way to classify the data. So in such cases, you have to be careful. So this confusion matrix is built. And then finally, the classification report is how far the algorithm properly works is the classification report. Okay. Then coming to the evaluation of regression. Okay, regression algorithm. So as here you draw a line, and depending upon which the data falls above the line or below the line or on the line, because based upon which you actually calculate the performance. Like here, the mean absolute error and the squared error, okay, and the root mean squared error, and all these things helps us in evaluating the regression algorithms. Okay. And now coming to the applications of where are the supervised learnings, supervised learning applied. Like as I said, in spam filtering and for image classification. Say for example, if you want to classify those images which have landscapes and those images which is on seashore, no, like otherwise things, so you can go for image classification. And also in medical diagnosis, of course, I think many of you will be aware of this. The system will be able to out of, if you are giving many data sets, sample data sets, it will be able to detect some of the medical conditions also. And also this fraud detection, like if you observe the pattern of a person of how long he has actually logged in, and what all, if he is actually accessing some sensitive data, then that goes to, I mean, fraud detection also. Likewise, when you come to natural language processing, like whenever a person speaks, how far you are able to understand the person's perspective. So thus that comes under natural language processing. And sometimes these are not only the applications of supervised learning, sometimes it actually shifts to unsupervised learning also, because initially what evolved is a supervised learning, and later on, okay, when they thought that supervised learning alone is not sufficient, they actually introduced unsupervised learning also. But before I get into unsupervised learning, let me conclude with this supervised learning with its advantage and disadvantage. Okay, so as I told you early, it is able to learn the relationships and the complex patterns. And if you are able to if you are able to train it properly, you will be able to give high level of accuracy. And it is also applicable to several domains and applications also. And if a clear objective is given, the performance will be up to the mark. So all these things and all is advantages of supervised learning. And coming to disadvantages, so These are all the disadvantages I just told you about. That is why we shift to unsupervised learning. Like so we have to label each and every data, and generalization sometimes for some data is not possible, and overfitting of the training data, and sometimes it is costly because it involves human supervision and all those things. So we all these things are the disadvantages of supervised learning. But sometimes when the data is limited, and if you are able to when the environment is very small, and you can go for supervised learning also, because the performance will be obviously better. Okay, so every method or every classification has its own advantage and disadvantage, as usual. Okay, then let us get into unsupervised learning. Okay, see, unsupervised learning is wherein you will not label the data. Okay, so there won't be any intervention of any person or anything like that. The raw data will be as it is fed. Okay, so it completely operates with unlabeled data, and you will try to discover patterns and structures on the given data, and based on which you categorize them. Okay, so let us now again try to understand it with an example, as how the same diagram, okay, relatively same diagram I have used. So here you have the raw input data with no, absolutely no labels, and now here the interpretation happens, okay, without any training data set, or labels or anything, and the algorithm actually processes it, and then after that you get the output accordingly. Okay, so now to move on to the next point, like the types of unsupervised learning, you have clustering. The first thing that we are going to discuss is clustering. Like when you plot the data that you get, you will be able to see some clusters. So depending upon the clusters, you try to name them, and accordingly you can classify them. So this is what clustering does, and there are certain algorithms that are used, okay, which includes k-means clustering, and hierarchical clustering, DB, that is density based scan, and the Gaussian mixture model. Each and everything is like a fine tuning of each and every model, because k means, in the sense, it just classifies the plane into k parameters, and then based upon which the clustering is done. And the hierarchical is wherein you have levels out of which you classify the data. And whereas density based is wherein, when you take the raw data, based upon the density of the data that you have plotted, you can do it. So the fine tuning of DB scan is the Gaussian mixture model and all these things. Then comes the next thing, which is association. That is, clustering is one thing, and association is the next type of the unsupervised learning. Like how far you are able to associate data, so depending upon which you classify the large data sets. Okay, so the a priori association rule that is used for market based analysis is used here. And then next comes the evaluation of unsupervised learning. Here you have some metrics, internal evaluation while you are performing the tests, and based upon the output, the external evaluation metrics, and the visual inspection, domain specific evaluation, or sometimes a cross validation, and human evaluation. All these are evaluation techniques employed in unsupervised learning. Then coming to the applications of unsupervised learning. Again, as I told you before, there are no clear, limits, like this has to be only done with this learning or something like that, because you can see here the natural language processing again falls under the application of unsupervised learning. And apart from which, the market segmentation and all strictly comes under the application of unsupervised learning, because high unpredictability and a lot of changing data, if we employ somebody to classify or name them, it will not be practically be possible. And anomaly detection, and the recommendation systems. Sometimes user may randomly look for some data one day, and he may not look into the data furthermore. So such kind of things can only be done with clustering. So we go for unsupervised learning here, and image and document clustering, and genomics and bioinformatics and neuroscience. All these comes under the applications of unsupervised learning. And again, coming to unsupervised learning, many things which fall under the disadvantages of supervised comes here as advantage here, because here you have flexibility, and you will be able to deal with large and complex data sets, and you don't have to label the data, and for exploratory data analysis and for feature engineering, it is very useful. And for all these things we go for unsupervised learning. Coming to the disadvantages of unsupervised learning. So what could be then the disadvantages? What could be? It is nothing but, again, when supervised learning is able to give you a proper, like the output, sometimes due to the outliers here, outliers in the sense those that doesn't match with the clusters. So those outliers or the noise are the biggest, trouble here. So sometimes they may be misleading, giving you different results. Okay, and how to how to classify them, the clusters, like which parts of the data to cluster in a single thing, like that, those things will be tough here. Okay, so these are all the issues. And sometimes the scalability issues also will be there, because it always handles with large data sets. How much data can it handle? So those things are also to be taken care of. So these are all the disadvantages of actually the unsupervised learning. Now coming to the next thing, the semi-supervised learning. It is a combination of, okay, semi-supervised in the sense it is a combination of supervised and the unsupervised learning. Like when you have some lot of unlabeled data, and you have a small amount of labeled data, then you go for semi-supervised learning. So as far as available, you try to label the data, and the other unlabeled data, you just treated them with the unsupervised model. So when you combine these two, it becomes semi-supervised learning. Okay. So then comes the reinforcement learning. The reinforcement learning is where actually we make the agents work in the actual environment. Okay, so with whatever if it gets encouragement or if it is given rewards, it will take it as a positive point, and those things will be recorded as plus. And say for example, if it is not able to perform well, so that also will be given as, like some, say for like punishments or something, like not exactly punishments, but in the sense a negative report. Okay, so if that is so, then it has to learn from that also. So it is an algorithm wherein it properly learns by interacting with the environment. So this is what is a reinforcement learning. For example, as how you drive in, like driving in a driving on the streets or playing games, all these things are like examples of reinforcement learning. Okay, then here comes the applications of reinforcement learning. Like as I told you, like robots which that drive the car, or which plays all these things, and or a master chess player. All these things are examples of, because the chess player has to predict the move of the other person who is actually playing with them. So it needs more intelligence and learning from the moves that the other person makes. Okay, so anticipating whatever he does involves a lot of learning. Okay, so these things comes under the applications of reinforcement learning. And then coming so whatever we have discussed so far are the main things, like supervised, unsupervised, and then semi-supervised, which actually involves both, and then the reinforcement learning, which completely works on the environment. Here are the other things which I just wanted to tell you, like batch learning, which actually learns in batches, because it doesn't like learn then and there. Like after getting all the available data, it will be trained and then it will be given. So wherever it is possible, and we have time to train the data in such environments, we can go for batch learning. And online learning is wherein those changes will be fed to the algorithms then and there in many batches, so that on the go you can be updated. So this is an online learning. And now coming to the major challenges that machine learning faces. Okay, so when you as we saw so far, okay, so machine learning is one of the important things that we need as of now, because coming to artificial intelligence in the sense, why do humans are branded intelligent, is because they continuously learn. They keep on learning and learning and learning, and they are also able to adapt to the changes. So likewise, the machine learning also have to change, and the algorithms also must change. I mean, like, will be keeping on changing, and all these things will be done. But what are all the major challenges that it faces is poor quality of data. Say for example, if you are not able to give the proper training data. Okay, so as of now, sometimes you may even see, like, when you are going for a job, you work in a place, if you are not exposed to several or different capacities, you will not be able to learn properly. So one side, the pure quality of data is also one of the challenges in in the machine learning. And underfitting of training data and overfitting of training data. That is, overfitting in the sense, like whatever training data is given, the algorithm will be able to respond properly. Okay, but whereas for other data, it won't be able to properly respond. So that is overfitting. And underfitting is sometimes the data will be very meager, that the learning algorithm will not even learn anything. So like, that is the underfitting of data. And sometimes the environment itself becomes complex. So those things also are also hindrances for learning process. And as I told you before, the lack of training data and the slow implementation. And the why slow implementation? Because many of them involves several human interventions and all those things, so it can't be done as how the other programs can be run. Okay, so, and the imperfections in the algorithms, all these things are major challenges in machine learning. And now I hope that I have covered from the beginning, like I have been telling you the an overview of artificial intelligence and machine learning and how they go hand in hand. And after that, I have been discussing with you about how a learning system, and then four components, like how does a critic help, and the performance, how it learns from that, and all those things I told you. And then we slowly moved into the algorithms, wherein I classified the algorithms, and I just told you all those things. And here I have also presented the challenges that machine learning faces. And do anyone have any queries? So do anyone have any queries? If you have anything, feel free to ask.
If audience have any questions, the feel free to ask to our speaker. She is ready to answer for your questions. You may ask question or else you may send in chat box. So the before asking question, we'll have a session like where the machine learning will act as a major role. Here, the machine learning is transforming into the industries at an incredible pace. It means that how the machine learning will act a role in the industries. We'll look on it. So ML algorithms can identify the patterns and automate the task and make the predictions that where once the unimaginable things will be happen. Here, the breakdown of how machine learning is revolutioning the various industries. So how the demand will increase. We all know that the demand will be increasing day by day. So how to handle such a demand in the industries, so we should go for a technology like machine learning. From that we may predict the future as well as the predict the expectation of the customer as well. So the predictive maintenance, so it means that in manufacturing the ML can analyze the sensor the data from the equipment to predict when failure might occur, and also it will give us the smooth operation in the industry. So and the second most thing in the role of ML in industry is the quality control. So the ML algorithm can be trained to detect the defect in the products during the manufacturing process with high accuracy. The thing is, the human mistake will cause the severe effect while the manufacturing has been done or else after the manufacturing. So the ML algorithm can be trained to detect the defects as early as possible during the manufacturing processes. This reduces the waste and ensure the consistent of the product quality. And then the third thing is the demand forecasting. It means that by analyzing the historical sales data, we have a sales data, right? So it is a historical sales data and the market trends. So ML can be the predict the future demand for the product. This allows the business to optimize the inventory levels and avoid the stockouts and improve overall the supply chain efficiently. So, what kind of experience it gives in the sense the product recommendations, chatbot, and virtual assistants and fraud detections. So, how it will give the enhanced experience in the sense the e-commerce platforms leverage ML to recommend the product to the customer based customer based expectation, and then it satisfy the level of expectations from the customer, and then that is personalize and improve the satisfaction of the customer and increase the sales. And then that the chatbot and virtual assistant, that is ML powers the chatbot that can answers the customer queries. So defaultly every customer have the default questions like so in that case no need for the human interaction. So whenever we programmed by using the ML, they spontaneously it will answer the customer queries, and then the troubleshoots the problem, and then the provides the real time support, and also the enhance the customer experience and reduce the human agents. And fraud detections, the third one is the financial institutions like the ML will analyze the transaction and identifies the fraudulent activity in real time, and also it protects the customer from the financial losses and safeguards the integrity of the financial systems. And then how it will help in decision making. So it will provide the improved decision making in terms of market research and analysis and risk management, then loan approvals. So every banks offer loan nowadays for their invention, creativity, entrepreneurships. So bank are increasingly using ML to analyze the requirement, also the validate the valid points from the uh, customers, as well as to loan approval process will be simplified and making them faster and more efficient. And then that risk management in the insurance industry, ML can be used to assess the risk as well as the potential customer, gives more accuracy, leading to fairer pricing and better risk migration strategies. And then that market research and analysis. So ML can analyze the vast amount of social media data as well as the customer reviews. The customer review will act as a major role in all the aspects. So with the help of ML, we can analyze the customer review, and then we can get the social media's data as well as the what kind of expectation and what kind of market nowadays, what market required now, and then what customer expecting now. That is what we are going to identify it in terms of customer preferences, and as well as and make the informed marketing decisions. From that we can smoothly make the decision based on the customer needs as well as the market strategies. So we conclude the session. If you have any doubt, you may feel free to ask. Our speaker is ready to answer the questions. I hope one question is received from Abdul, right? The question will be, can you elaborate on how different types of machine learning technique such as supervised, unsupervised, and reinforcement learning are best to apply the real world problems? So additionally, how do we determine which technique or model is most suitable for a specific applications, and considering the diverse range of available methods? Yes, speaker, the question is for you.
Yes, okay. So as I told you in the examples, like artificial intelligence environment actually differs. Like either the environment is fully observable or partially observable, or if it is deterministic or stochastic, or it is static or dynamic. Likewise, we have several environments, and the environments is actually described by the piece description, like performance, environment, actuators, and sensors. Okay, on which the environment here plays a major role. Because as you all know, like sensors are the input, actuators actually helps you to give the output, and performance are normally being evaluated here depending upon the environment. Say for example, if it is fully observable and a static environment, and if it is deterministic, and if it is all such things, we can actually go for an algorithm which have only, like limited data, like labeled data, like it can be supervised learning. Sometimes when the data is vast, and because it will only be partially observable, and it will be like a stochastic and dynamic, and in such environments you have to obviously move on to other learning techniques. And the same way, in such cases, we can also go for reinforcement learning also. I hope this would have like cleared your doubts. Is any other person having any other doubts?
So, and I would like to add few points for your question, Abdul. So, these three technique, how real time we can apply in the sense in the field of medical diagnosis support, as well as the self driving of cars and weather predictions. Nowadays, it's a crucial role for predicting the weather. Even if you are in Indonesia, right? We cannot predict the exact weather conditions and earthquake, environmental disasters will be uh, predict earlier with the help of these three algorithms, and then the recommendation systems, and then the fraud detections. These are all the real times applications which are using these three techniques, like supervised and unsupervised and reinforcement learning, using machine learning. If you have any questions, you may feel free to ask, or else you may post in the message box.
I think we don't have more question again, sure. Thank you. Yeah, before I just disable for our participant, please open your camera. I will take a picture of the phone of three. Okay, 1, 2, 3. Okay, another one, 2, 3. Okay, thank you. Thank you for your cooperation. Finally, we come to the end of this sitting lecture today. We would like to thank you for Professor Shoba and Noorul for the wonderful information and sharing your knowledge. We hope this information will be beneficial to our participants. At least we hope to have a collaboration in the future with Arunai Engineering College India. The visiting lecture for today and here. We have to see you soon. Thank you. And have a nice day. Bye-bye.
Thank you all.
Bye-bye.